So with that, we get in this morning to our first session. We have WPC Net Watch WFO Flash Flood Warning Application. So we have our two speakers this morning, Jenni Laflin from the President's Hill Office and Andrew Orrison from WPC. Are going to take us through a relatively local event here over the next hour or hour and a half. And so again, the procedure this morning will be as it was the last couple of days, 10-15 minutes of talk, 10-15 minutes of discussion, following the short clips. And again, for those that are here and for those that are online, please continue to use Slido to ask your questions and make your comments, and we'll go through those as they appear. So, and make sure that you're, my new favorite word of the week, upvoting. Hit that little thumb for the questions you'd like to see answered first up the top. So with that, we'll turn it over to Andrew and Jim.
Okay, good morning everyone. Thank you so much for having us here at the workshop. It's been a great week so far. I look forward to this last full day here. I'm Andrew Orrison. I'm the satellite focal point for WPC, and I'm also one of two focal points for our NetWatch desk, which is an ESO desk. It's the only one we have in WPC, and it's a dedicated desk for flash flooding, which is covered. And this is a rather exciting desk because we get to follow mesoscale meteorology at its best. And we've had a couple of great presentations already when we get into mesoscale this week here. So we're going to talk today, though, about the flash flood event which occurred here locally, July 26th and 27th of this year. And so when I worked the NetWatch desk, 3 shifts per day during the warm season. The harder the convective season, we're very, very active. So your weather system is active, more than likely flash flooding is going to be a secondary hazard. It's very active as well. And so on the morning here, July 26th, I wanted to start off with the day one SPC convective outlook. The main focus of attention was over the Midwest. And you can see how SPC actually from the overnight period prior had a slight risk area up across parts of northeast Kansas, northern Missouri, going through central, southeastern areas of Iowa, and into west central Illinois. And that was basically where the best forcing was going to be setting up for this 24-hour period. So this is 12Z to 12Z, okay, going all the way through the 27th here. So that's what we were looking at the main focus area. And that's where the guidance from the overnight period was actually the most emphatic about there being organized convection. This was the case on this day here, and I'll also, here in a couple of minutes, the 500 millibar clock from 12Z, but we have a front that's coming down from the upper Midwest. We had a troughing through here as well, and with that in mind, we had ample conditions, or at least forecast conditions, to be actually seeing severe weather potential out across parts of the Midwest. Favorable shear, favorable instability that was forecast to be in place, and enforcing mechanisms through a deeper layer of the column as well to get the convection to initiate. So this is what, in WPC, this is what we had produced from the overnight period. Same 24-hour window, and the idea was that we were going to see a max of precip here across the general same area where SPC had their slight risk area. We had heavier rainfall that we were forecasting, at least from an airline average perspective, which is SIS, and we had mainly for northern portions of Missouri, up into parts of southern, southeastern Iowa, and over into Illinois. The key again is that this was where the model focus was for the heavier precipitation. A lot of the global models going into this event here had the precipitation, and particularly convection, concentrated in this area here, global models as well as high resolution models. The briefing I got this particular morning when I came in on the NetWatch desk was rather emphatic that there was going to be rather organized convection in through here. Okay, and then we had sort of this southwestern tangent of convection here where we thought that there would be some precipitation, and not necessarily real organized or real heavy. Okay, but that's what we were going with going into the 24-hour period. And actually, much of this, just like with SPC, the main period in which this was going to happen was going to be for a 12-hour period from 0Z on the 27th through 12Z on the 27th. Okay, so this wasn't necessarily going to be during the day on the 26th. It was going to be toward evening into the following overnight period. Okay? And so what we had collaborated in conjunction with the WFOs from the night before with our excessive rainfall outlook was a rather broad area for a slight risk here exceeding flashlight guidance values in this case, all right? And we actually had a rather enhanced area here where we had this moderate risk, which we had coordinated, and this is based on the fact that we had agreement, at least with the global models, and to an extent the high-risk guidance, not only had the rainfall in there, but one of the problems that we had going into that event was that we had relatively wet antecedent conditions. So typically when we have a QPF, we're only going for about 2 to 3 inches of aerial average for QPF. We would not necessarily have a moderate risk out. Antecedent conditions are critical in this situation, but in this case, because we had convection that was ongoing from earlier in the week, we actually had one presentation yesterday which kind of alluded to some of the convection in the upper Midwest, troughing up there. On this period, things were kind of settling down to the south, so we did have the moderate risk area that was in place. And so Jenny, we had coordinated the moderate risk area, and we had some flash flooding hazards that were going to be at the local level here. So did you take with this?
So looking at, we'll jump into a lot of meteorology after we talk about this, but looking at some of those pre-existing conditions, we had ongoing showers of thunderstorms, even north of the Missouri River that morning. Even in Kansas City, within the last couple of days, they've had almost 2 inches of rain measured in the sky. So again, those wet conditions pre-existing, all of those ingredients that you look for heavy rain. So coordinated that watch with our neighbors and with WPC as well, mainly focusing where you saw that heavier axis of precipitation forecast by the models and by WPC. So that was really the area that we were focusing with going into this period. This was issued at about 3 o'clock in the morning on the 26th. So almost 24 hours before we were expecting the heavy rain to be impacting us. And then you can see on this graphic as well, we had highlighted that chance for severe storms. With those ongoing showers of thunderstorms, we were thinking it was going to be a little bit further south than where we have that watch issued for flash flooding. Basically assuming that something was going to maybe develop south of that boundary in the warm sector, and that maybe as we went into the evening, we would see a little bit of severe activity kind of on the south end of where we were expecting that flooding.
Okay, so this is what the 12Z upper air plot looked like here. This is 500 millibars that morning on the 26th. You can see up here to the north, we had an upper trough coming through the upper Midwest region. In here, relatively stronger wind fields here at 500 coming all the way down from, say, Wisconsin, southwestern down to Nebraska. In here, it's right from the outset, stronger wind fields here, more shear going on already in the upper Midwest, sort of playing into the role where severe weather potentially could be a little bit farther north. But of course, that's only one ingredient, right? We need to have moisture transport, we need the instability in there as well. You don't want to be capped either. But what's really kind of key here this morning in particular, and I specifically remember coming in on shift, is that we had a relatively broad area of convection that's already on the point here. It's already had relatively decent dynamics. It's sort of kinky here, 500 millibars across parts of our southeast South Dakota, northwest Iowa in this case. And then there's a little bit of a break here, but you can sort of see some of the curvature down in the parts of Nebraska. But down here in the Kansas, you can see just from the western and central part of Kansas here, Dodge City over towards the Topeka area, you can see some of the curvature in the wind field in there. So we actually had a case where there were a couple of perturbations in the mid and upper level flow going across Kansas, and that was responsible for also driving some convection down here as well. That was actually very, very critical. You'll see here as we move forward with this presentation how that convection really kind of manifested itself in a way that it kind of racked the ability of the model forecast for overnight to be accurate. And even with the 12Z guidance, how there were some problems in handling some of the features going on in through here. So there were problems right from the outset here at 12Z. So we actually did have features here in Kansas where we did have clearly some evidence of some perturbations in here. I don't have the vorticity fields there, but you can sort of see how you had the cyclonic curvature here. So you already had basically a forcing mechanism that was driving some of that early morning convection there. And that was something that WPC and SPC both were concerned about because we want to have that instability built up throughout the day. You want to get that thermal heating. And so models for overnight, like we were talking about, where our forecast bed precip farther north here, based on the overnight guidance, that's going to be correct. We don't necessarily want a lot of this ongoing activity here farther down to the south. So One thing to go ahead and point out here, right before we get into the 12Z NAM, that's fine, yeah, we'll load this up here. So this is actually rated 12Z. 12Z guidance is starting to come in. Now actually at 10 o'clock that morning, 15Z, WPC actually issued its very first business scale domain request. And I actually personally went to the SDM and went through the VLAB as well to make that request for 1-minute imagery. Talked about it with our SDF on shift that day. This is an opportunity because we actually did not have one requested at this point. Mid-morning, around 15Z, there was not one that was out for 1-minute imagery out here across the Midwest. WPC had a moderate risk, okay? SBC had a slight risk, okay, but this was early. There were no requests that were in play at that time. And so given the uncertainty over the initial conditions, basically what we saw with 12Z layout data, our millbar plot, and the concerns of the overnight guidance possibly being too far north already with organized convection, we decided to go ahead and put out an ND request for the Midwest area here so we could get the 1-minute imagery and sort of enhance our ability to make the decision a little bit easier, have better confidence in the forecast process throughout the day and overnight. We actually had the request go through 12Z the following morning on the 27th. So this is the 12Z NAM here, and this is at 500 millibars. See the heights here along with the winds. And one thing that I noticed right from the get-go with the 12Z NAM that day was how it didn't appear that there was enough curvature in the wind field here out across parts of Kansas. You can see how the wind flow is fairly rather uniform here, all out west, southwest, maybe southwest here towards Topeka. 500 millibar plot for 12Z clearly showed a little bit more curvature to the wind field there, so suggesting that there's a little bit stronger energy, stronger shortwave trough that was in place there across that area. Now the NAM, as we go through here, this is 318Z. You can see how it's got a very well-defined kink up here across Iowa. So much sharper with the upper trough here, suggesting stronger forcing in that area. And then down here across Kansas, we actually got just a little bit of a low amplitude shortwave ridge in place here too. We got some northwesterly flow here, 500 millibars, and got some of the troughing that's actually kind of sunk down into parts of northeast Kansas and far northwest Missouri. So let's go forward here through about 21Z there. That's good. And you can sort of see in here how the NAM at this point, it has much of its energy well off here to the east. Okay, in fact, it's already going into parts of Illinois, southern Wisconsin, and into northern Missouri. And if we could there, Chad, let's pull up the QPF. Let's go, start with 12Z, go through 18Z, and go up to 21Z through there. So going through the period, so that's 15Z. Notice how once all the convection farther north, right from the outset, notice how there's not a lot going on here across Kansas. There's some very, very widely scattered shower activity. And that's out through 21Z at that point. Overwhelmingly stronger area convections up here in Iowa at that point. Which makes sense, right? Because that's where the stronger force is, 500 millibars. All right? We've got some of these stronger wind fields in here as well, so we've got some shear. Now it's kind of, the mindset going into the day is that we have organized convection farther north, as well as getting some of the instability up there for heavy rainfall as well. Okay, so this is through 3Z here. Notice just how the NAM does not really have a lot going on here across northeast Kansas and northwest Missouri. Everything's well downstream here across parts of Illinois. And if we could just back up a little bit, go back to 0Z there, Chad. At this point here, the NAM actually does suggest that there could be some perturbations in through here, but it doesn't necessarily have a whole lot of convection. Overwhelmingly wants to focus the greater activity much farther off to the north and east. We have the pull up the cape there at that point. That puts a little, yeah, there we go. You can see in here, this is the, so that's the mixed layer cape. So we're just going to get in through here and pull it on there. Okay. The cape in here overwhelmingly was quite high at this point. This is actually where I think the NAM actually did relatively well in this situation. So you had a thermodynamically very favorable environment for convection to really initiate through this area. However, all the stronger forcing might be just seen with 500 millibar flight as well to the north and east up here into areas of east central Iowa going into Illinois. So you have a bit of this connection, if you will, okay, with a favorable ingredients organized connection at that point, all right? You can sort of see some things going on in here with potentially NAM trying to have some sort of outlook down the well off here to the north and east across parts of Missouri, which makes sense because that's where some of the connections have been organized in there as well. Okay, and back here in Kansas, you got the southwestward extension and stability. That was all pulled along our front. There was a front out here at the same time. All right, so we were, at least earlier in the day, expecting there to be convection breakdown through here. The other thing, which Chad is doing a really good job of showing, is just how moist the environment is. We basically had a tropical air mass in place this day. It actually got more moist at the time throughout the mid and late afternoon hours going towards 0C here. So these ingredients in place, high PWs, very high CAPE in place. You're asking for convection that could potentially be extremely aggressive when it comes to rainfall, very efficient rainfall processes, okay? Now, having PWs that high, you're implying a pretty deep warm layer as it is. So you're going to be talking about efficient rainfall processes where you get enhanced rates in this situation here. And to the extent that you can get deep convection, you really maximize the ability to take advantage of that warm layer. Okay? You're getting very strong updrafts, and that's really key with cold cloud tops and already a deep warm layer, really maximize that rainfall rate potential in particular. Can we show the 850 winds just real quick? We have the thing out there. Yeah, let me see. A little bit. Okay. Low-level jet out here, that's fine. We'll just park it there at 0C. Was not real strong, okay? It really was not that strong throughout the whole day. All right, but we did have southwest flow out here, a good 25 to 30 knots, and you can see quite clearly where the front was out through here. And so this was going to be, in a sense, your forcing mechanism up through here, which if the name was correct, all right, you could get convection that sort of break out through here, but we also know that the NAM at 500 millibars had much of a stronger troughing farther to the north, up here across Iowa and Illinois. We didn't really see it so much down here to the southwest, where you got some of these better thermodynamics, and at least a relatively favorable southwest local jet, not that strong, but modest at least. Sometimes modest can do the trick when you have all the other ingredients in place. All right, so let's go ahead and move forward, Chad. Let's get to the satellite imagery here. We're kind of start this off here. So this is the GOES-16 channel 2, 0.64 micron visible satellite imagery. And the one thing I really want to kind of point out through here, first of all, the boundary, the low-level boundary, sort of shows up pretty well here in the surface observations. All right, you can see this northeast wind up here, Chinook, and here, Manhattan's out in the southeast, Topeka's generally out in the south-southeast through here, and once you get into areas of Missouri, over here, the winds are generally out south, although there are some pockets of convection going on through there.
We've jumped ahead to the late afternoon, too.
I'm sorry.
We've jumped ahead to 20 TZ.
Exactly. And that's great because at this point, there's one key feature I want to point out here, and that's that, of course, on one hand, we have very strong convection going on out through here, east of Hutchinson and west of Emporia, this general vicinity through here. Relatively localized convection, okay, that worked out because we were able to go ahead and essentially break any kind of cap that was in place. We did have the front gradually sinking down through there, but you had good instability and a pretty high moisture environment through here. But what is more important is what's going on up here across parts of northeast Kansas. What you can sort of see here is certainly some higher thin cirrus in here, and you've got some different texture going on around Kansas City, down here towards Topeka, areas farther down to the south into areas of west central Missouri through here. What this was, and if we can pull up the infrared, we have the infrared. Notice how the cloud tops with this with time going through the late afternoon hours that day are gradually weakening in through here. What this was essentially the dying remnants of the MCS from earlier in the day, which the NAM did not actively detect. Radar had shown it through here. This is well back off to the west, all the way from 12T through 18T. And it was convection that had stayed relatively organized through the period And so we got to the point where, because of the convection going on farther down to the south and west, didn't have nearly the moisture and instability transport into this area of convection here. So the support for this is weakening with time, but you can infer an MCV through here. Visible satellite imagery also suggests that. If you look at the low-level cloud field, we can go back to the bits real quick there. You can really sort of sense how, with this dying MCS in here, you've got some signature here, just some outflow of the high cirrus in here. You've got to really look kind of closely here. It shows up also infrared as well, where you've got some high-level outflow going on. But in the low and mid levels, you've got some cyclonic curvature through there. You can go back to the surface ops as well. You can sort of see how you've got some broad cyclonic curvature all through here. Also parts of east central Kansas and farther off to the east here, getting toward the Missouri border. Back here farther to the west, you eventually get to the point where the front, actually the front in this case is well up here to the north and west, but it's coming down to the southeast here, so around the 21C to 22C time period. But we actually have farther down here, for example, the northeast wind Chinook, we actually do have a pretty well-defined boundary to kind of lay down through here. And I see the Emporia actually there with the wind out the east later in the day. So we had an outflow boundary which had been laid down by the convection earlier in the day, and that NCV really sort of helped anchor that outflow boundary. The convection was persistent enough that you had forcing along this boundary here that was going to be in place later on in the afternoon. Tulsi Dam did not at all pick up on that. Okay, remember, we wanted to have much more of its convection organized up here to the north, and so far, I mean, to some degree, we're seeing that, especially way over here, parts of southeast Iowa, but you're not seeing quite the organization of the dam forecast. Okay, so this is critical for what's going to happen here in a couple of hours going forward to 0Z. The next block will get into that. Okay?
All right, so just to reorient you, we're still 6, 8, 10 hours away from the main event, right? So we're still,
that's exactly right.
We're still setting the stage here.
Yeah. So even though some of this convection looks really good, it's not the main event at all. Not that the local offices would be looking at this for WPC from a methodological perspective, but we knew that this was not going to be the main event here because the models had been signaling organized convection far to the north.
All right, we'll start local and then fill up the slide out. Folks in the audience, questions, comments for Jenny and Andrew. Okay, so we'll go up the slide out. Question 1, look at that 5 of those. I don't think it shows this, Chad, but what did the GOES-16 derive to go over some of the watershed? Now, actually, I don't remember, I don't know if by late July we had.
They were we're starting the trickle line, and yeah, we do not have access to them.
We didn't have access to that information for this event.
That's right. We do look at, for what it's worth, we do look at the Rock TPW
From GOES-16.
From GOES-16, we do have procedures where we do look at it.
I think the next question is the same answer that would apply.
Same answer would apply.
Were you able to use GOES-16 derived motion winds on this date to determine whether or not the model was accurate? Although interesting side of the validated model.
I've been a very strong advocate for the AOVs, and I'm very much looking forward to seeing that in our AWIPS system as well as our AWIPS platform moving forward here. So, I really do believe that the derived motion winds are going to be a key factor in trying to do some critical model diagnostics, and especially on the mesoscale for single run purposes and also with flash volume.
Next question from Slido. How did the 3 GOES-16 water vapor channels agree with what the model analysis showed?
Okay.
So stand by here.
Sure.
See if I can get the correct videos.
And just so it's out there, this is
I was going to say, do you like that answer? a setup so somebody can say you like this.
This is not my favorite curve, okay? Personally, I'm much more.
You have a fan out there, that's somewhere out there.
That's great. I think every forecaster should pick the curve that's most appropriate, or at least gives them the most comfort level when it comes to looking at GOES injury in general. In this case here, and
it shows the NISX product.
It does. In the water vapor imagery, and actually, it's not just one channel either, it's all three of them. It's the entire water vapor suite. We will be looking at these to identify shortwave impulses. And what's really nice about the three water vapor channels is that you can sort of get an accounting of the column, which some of these features are evolving with time here. So you get low-level water vapor features, okay, maybe towards that sensitivity higher up there, about 403 millibars, so you can see the detail. This actually does show the outflow quite well going down through here. In fact, this was great where we sort of applied an MCV here in conjunction with physical satellite imagery across northeast Kansas, but we've got a nice outflow down here, so transverse banding features there across the southern Missouri. This is not relevant to what's going on for later on in Kansas, probably more in the Kansas City area or central Missouri, but nevertheless, features you get to point out.
Andrew, are there any signs right now, like this afternoon, that the NAM was going to be considerably, off? Or would you guys still be thinking that things were still further north? Because this is a very messy situation.
And that's one of the problems that we had throughout the day from a QPF perspective. I'm sure with SVC that day, they were pulling their hair out. Because actually throughout the day, SVC, they actually had downgraded their slight risk down to a marginal through here. And one of the key problems was that you had a lot of cloud cover here, which clearly illustrated what it is. That was really inhibiting some of the instability, at least in the management layers. Some of the instability was certainly established the loft, all right, in an elevated sense, but by not getting the surface-based instability to be in place, and not having that juxtaposed with better forcing to the north when we had the shear, severe weather potential certainly was not looking as good for the north. So organized convection in general is becoming problematic. And you see it here, we've got multiple clusters going on all over the place across the Midwest and through here. The problem with the NAM, this was not just the NAM, it was many other models that day. It was the high-risk models, it was even her guidance. I was on this particular day here. None of those models really handled this particular area of infection that had all across north central Kansas, eventually east central Kansas particularly well. This MCV was not at all well handled. And so that was telling me that we had all kinds of problems with the 12Z guidance that we had about.
Okay, we'll do one more. I think actually you answered this question, distribution city question, based on the short-term high-risk guidance. Let's actually look at the last question. Throughout the event, because maybe you all in this little model, just think about this initially here. Can you comment on the value of the 1 minute versus 5 minute data? So you mentioned, of course, again, that you all have requested the NPS sector to be.
That's right.
I'm sure it was nice to have, but can you describe what features you're able to resolve better with 1 minute data with respect to the rainfall potential?
So the features really with the 1 minute imagery going through that afternoon was that you could sort of try to get a sense of what level of organization the individual updrafts were taking, whether or not they were sustainable. Now in this case here, we had a lot of convection that was kind of going up all over the place in here. So you had multiple small scale clusters in there. 5 minute imagery certainly would have illustrated this quite nicely. The additional benefit of the 1 minute imagery is to kind of get a sense of whether or not you're getting a lot of other updrafts that are going to be producing convection in the near term. So you can sort of get a little bit of a better sense of how the convection is organizing or becoming less organized with time. There's no doubt 5 minute imagery is great. 1 minute imagery, of course, is nice to have. In this case here, the 1 minute imagery will not necessarily give us a whole lot of extra value per se, but it does tell more of the story that's going on. As we move into the overnight period, I'll try to illustrate how 1 minute data actually gave even better in telling the full story of what was actually going on from an organization standpoint.
Okay, anybody else locally? Any last questions or comments before we move on? Steve.
you about, in general, things like atmospheric rivers and large changes in moisture. Do you find that the three-level moisture, or maybe the low-level moisture in particular, and maybe down the road, the high ocean winds in between these gas and microwave observations will prove to be useful? Because it's not clear that GOES, is the best observing platform, but maybe there's still value.
That's right, yeah. It's one of the limitations with polar orbiters is that we still do have some, we have the issue of latency in there, even though that's getting better over time. And then the GPS series will help to address that to a point. But great thing with GOES-16, 17, once we have 17 up there and operational, atmospheric rivers can actually be much more identifiable through the column with water vapor swings. It's not like the lengths of GOES we just have that old 6.7 micron channel in there, it's the mid-level water vapor. Now you can actually see more of a three-dimensional element to the depth, really, with the water vapor. So it does actually give you an accounting for atmospheric rivers as to just how deep that moisture layer is. The deeper the moisture with atmospheric rivers, in general, the higher your rainfall potential is going to be. So that in conjunction with TPW as well, I think looking at the water vapor channels with TPW, so the level 2 products, I think can be very, very helpful to better define with the atmospheric rivers and make a forecast. And it should give you better confidence as well in what you're seeing. So you're seeing it's much more of a layer as well. Previous, GOES that we have, GOES 13, that series up to 15, they will go ahead and show some idea of what you're dealing with. Now you just have more of an accounting of the details throughout the column. All right, so for the second block here, this is the 0Z sounding out of Topeka here. And what you can see rather clearly here is that we're not only quite unstable, but we're also very, very moist. We're talking about PPWs in the previous block. And PPWs of over 2.5 inches locally and through here. And so this is basically a tropical sound here. We're pretty close to one. You have a little bit of dry air up here, possibly around 400 millibars. But in general, you're pretty unstable. A couple of things to point out. When we talk about the MCV that was going through parts of east central Kansas, that at this point in the 0Z time frame has already gotten into areas of west central Missouri. You see 500 millibars here on the back side of that NCV, winds around the northwest here at 20 knots. Meanwhile, down at 850 here, you've got 30 knots out the southwest, all right? So you actually have some varying winds here, here with heights. You've got more convection going on at this time through here. And in the low levels, very lowest of levels here, boundary layer, winds are light out in the southeast. That implies you got a boundary down here southwest. All right, so just keep those things in mind at this point here. Okay, so 23Z, starting point here, and get this to load up. So MCV here, going into the areas of west central Missouri at this point, and towards the 0Z time frame here. Of course, early winds convection down here around Emporia. This is actually starting to weaken with time in here. It's actually in a all apart. We actually look at the infrared here in a minute. But what I want to point out in particular is that we've got all of a sudden a series of very strong updrafts going on with enhanced TCU, strong convection, and overshooting tops going on up here northwest of Topeka, north of Manhattan, and through this region in here. And if we could pull up the VTAR plot there, Chad. Notice where the boundary is. Okay, now up here, got all kinds of northeast, easterly winds in here. Winds are actually a little sort of variabilized here around Kansas City there. Very out southeast, that's a weak southeast wind in there. You can see how you had northeast flow all through here. But look at these dew points in here, generally mid upper 70s, tropical environment for sure, the boundary layer. All right, and you can sort of imply where the front, not the front, but the outflow boundary is down here. Way down to the south, parts of west central, southwest Missouri here, you see temperatures in the 90s here across south central Missouri, and back here to the west, boundary would be down here in the southeast part of Kansas, temperatures from the low 90s, and where some of this convection is going on, got mid 70s, and at best temperatures up here farther north are upper 70s or 80 degrees. Back here towards Salina, temperature there is about 90 degrees, we're pretty close to where the edge of the south boundary would have been. So strong convection going on up here to the north, nice overshooting tops in through here. Remember, the Topeka Sounding was showing a southwest little jet, okay, at 30 knots at this point. And what you can sort of see in here, if we can actually, so we'll pull up the infrared in there for right now. So how explosively cold stops got. It goes down to the south, moving tops through here, convection is weakening through here, and as that's weakening, convection is initiating, taking over very aggressively here farther to the north. So whereas before you may have had that local jet being intercepted down here with this convection to the southwest, not to mention where you have rather unstable air, you're having it initiate up here to the north at a favorable time period getting towards 0Z where the local jet is not being intercepted here to the south, it's now being intercepted up here farther to the north, and it's already going to be overrunning this outflow boundary here to begin with, right? One of the keys too is that with this dying MCV, you probably have a tailing axis of volticity out through here, coming down from the northwest down to the southeast. But you got the local jet out to the southwest. You already had a very unstable air mass kind of pulled up here to begin with. Okay, it just hadn't necessarily been all you stop, even with your other convection of the day. But with the increasing of the southwest local jet, especially in a nocturnal sense at 0Z, which is common out in the plains, right? So we have the nocturnal local jet tend to increase. And as that's increasing, you're enhancing the warm convection. You already have a boundary to the south, so you sort of have kind of an isotropic situation here where you're getting warm convection, but because you're so unstable, you're getting upright convection at this point, quite explosive. You can see some of these very cold tops up here, nice overshooting tops. And so on the MapWatch desk about this time period, it's sort of seeing this line up with the mean flow from west-northwest to east-southeast, and with a local jet coming around from the southwest and interacting, overrunning this boundary here. That was giving us a lot of confidence to start putting out the NPD. And so ultimately that's what we wanted to go ahead and do, because we knew that this was already very moist, unstable air mass, had a boundary which the models had not identified at all with a boundary layer. And so right after 0Z, we began crafting our first NPD for the event. You can see here how we identified the MCV, also West Central Missouri. We talked about this sort of low-level trough axis that was actually extended back from the MCV itself. And so we actually had different levels in here. This was not necessarily right at the surface up here, because at the surface we have more going on farther down to the south. But let's say the 925, 850 millibar level, you have a bit of a trough axis actually extending back from the MCV, and it sort of anchored that from the afternoon hours. This was extending back into the west-northwest, and you had a low jet overrunning that. So that's where you're getting a convective initiation to really take place. So it was kind of facilitated by the increasing of the nocturnal portion of that nocturnal local jet at that point. The PWs we talked about, 2.5 inches per hour, very intense rainfall rates, very warm rain processes in place in there. And so we were talking about, just from the outset here, 2.5 inches of rainfall in an hour, more than likely you're going to probably have flash flooding concerns pretty quickly, especially when you're looking at a training convection scenario there. And already right at the end of that Saturday, when we were just looking at, convection was beginning to line up a bit from the west-northwest and east-southeast, and beginning to train with the mid-level flood, the mean-layer flood, I should say. So what we highlighted in the NPD itself here, we talked specifically about the GOES-16 imagery, depicting a vertically stacked surface of 850 millibar low, revealed in, okay, strengthening southwest local jet towards Manhattan and into the city of Kansas City. Main cold front, the synoptic boundary was settling down to the southeast. We talked about on the mesoscale what was going on farther down to the south, or across parts of southern, south central Kansas into Missouri through here. So you had slow local jet, speed convergence in through here, and really kind of a favorable environment for convection to really initiate. We actually talked about how we had some weak anticyclonic curvature of speed convergence in conjunction with a deeper layer moisture convergence across this area. And so that interacting with the trough coming back from the MCD is really kind of what set the stage through there. We have multiple ingredients coming into place at the same time. Talked about the sounding as well. We had plenty of caping in place here. Rather unstable, this is moderately unstable air mass, and rather impressive given how much moisture was actually in place as well throughout the column. And you can see how we made a specific mention with the infrared, the visible imagery that we were just looking at there about the intense shooting tops that were taking place. That shows a lot of organization. When you're seeing an explosion of very cold tops, and you're seeing that texture of visible satellite imagery. It's telling the MetWatch forecaster overall that you're seeing plenty of organization. It's all about trends really at that point. You know, when it comes to whether or not you're going to have a long flash flood event moving forward here. It's not that you just have one cell or two cells go up. Okay, you want to see multiple cells all going up at the same time, because what's going to ultimately happen, more than likely, is that these cells are going to eventually merge. So you get into other dynamics and complexities when it comes to the evolving hazards. So whether something is one of them, but from a flash flood perspective, okay, it's the evolution of all these components in here. So you've got, you know, multiple cells, and they don't necessarily have to be supercells per se. It can be multicellular convective, but when they come together, they submerge, you end up with organized NCS-style convection, and then you have to assess other parameters at that point. Is it going to train over the same area? Are you going to have a QLCS? Okay, are you going to train line segments or any kind of repeating activity that would really enhance the flash flood potential? This in particular is kind of a dangerous setup here because we're already looking at the mean layer flow coming out of the west-northwest. Convection was initiating along this elongated west-northwest, east-southeast axis through here with the trophy dimension. So training potential was pretty well established at this point. So we did put out the NPD, talked about the training, and at this point, 3 to 5 inches may be possible leading to flash flooding concerns throughout this valid time period. This takes us through 6C at this point. We said flash flooding possible just through that particular window. So this was communicated with the FOs, which we always do with our NPDs. When we go ahead and issue them, you coordinate with the FO, coordinate our thoughts, and we don't just necessarily put this out there and have it be for the FO to try to find for themselves. Personally, I like to go ahead and issue the NPD and then provide follow-up thought, either through NOAA's chat or with the collaboration tool within AWIPS. It's a situation actually where we're more uncertain of what's going on. We can actually do pre-coordination as well. I think in this case here, I was all shift at this point here. I'm not necessarily sure if we did a lot of pre-coordination for the NPD because we already have, Jenny, we had the flash flood watches that were already out at the local level at that point there. And of course the moderate risk to the excessive from earlier today. So it wasn't like we could do a whole lot of other coordination on some of the details going into the event, but it was a matter of just trying to find out when the time is going to be right for convection to really get going. Not having it up here in Iowa like the NAM had, but having it farther down to the south. Once we saw the main focus, all the ingredients coming together, this is where we wanted to see the main flight area. That's where the convection got going, so then we communicated with the field at that point.
I don't want to steal the thunder of the next part where we'll talk about this, but there actually was really good collaboration between WPC and the office, because you can see the time on this MPD that comes out 9:34 Eastern time. An hour later, the flash flood watch was updated as well to be pulled further south. So all of this communication going on helps not only their coordination with the office, but then the office's communication outwardly as well. So there was a lot of collaboration going on at this time and discussion back and forth as the situation developed.
Right. Hey, Jenny, can you talk for a minute before we open up to everybody? So now we're at the 0Z time frame. The MPD comes out probably about 2Z. I don't know if you're walking the door at this point, but give us a sense of what's going on at the office in terms of the awareness is there now. It's going to be an evening event. What kind of support / DSS at this point you all have you done and are you planning on doing, given this is going to be a nocturnal event?
Right, and I would say the biggest shift that happened throughout the day, we talked about SBC had downgraded to marginal. We definitely changed our messaging throughout the day to be, we're not worried about severe weather anymore. we're worried about these ingredients for flash flooding. And even though we weren't highlighting the Kansas City Metro initially, the message that was still going out was that these storms, when they develop, are going to be extremely efficient. We're going to see flash flooding. And so regardless of exactly where that was pinpointed, that was definitely the message. And I looked back through our NWS chat logs where we were communicating back and forth with partners, and a lot of them were asking, hey, are we still going to have severe weather? What do we need to do to prepare for the afternoon and the evening? And it was definitely, this is a heavy rain event. This is a flash flooding event. And that's a very different thing for them because a lot of the counties have their own spotters. They send them out if there's going to be severe weather. But you don't want to send them out if there's going to be flash flooding. You don't want to put them in flood-prone areas to watch for severe weather when that's not the main threat. So that was definitely the communication throughout the day. It was just when these storms develop, there's some uncertainty in where they're going to develop, but when they do, it's a flash flood event. We're really worried about these high rainfall rates. So I think that was one communication that we were really able to receive throughout the day. Also, looking at this, and especially just looking at the observations, if you didn't have this high-res satellite data, your odds are all over the place. You clearly have this outflow boundary to the south, your synoptic boundary is nowhere to be seen. You've got a return flow to the southwest up in Maryville, and then some sort of light westerly flow in St. Joe. You've got boundaries everywhere. So looking at this evening satellite, you're able to see which boundary is important. I've got boundaries everywhere. Well, the robust convection that you're seeing developing in northeast Kansas tells you where do I need to look as a forecaster, where do I need to be focusing as we go into the next several hours, which of these boundaries is important. And I really think that kind of helped feed the next few stages where we were able to say, okay, maybe we need to be watching this. We're not looking for severe weather. We already determined that our severe threat has gone down. So now this is where we're focusing for these high rainfall rates. This is where we're going to be focusing for that flash flood threat. And the satellite really, really helps figure out which area specifically do we need to be focusing on.
Yeah, just one follow-up too. One thing I wanted to point out. Up here, a little bit farther to the north and west, you can sort of see some of the texture in the vids back here. So northeast of Chanute there, north of Manhattan. I'm sorry, that's TNK. That is Concordia, excuse me. I think Chanute's farther south. Southeast. So up in this general vicinity here, you sort of see an agitated level of Q that's ongoing. Some of it's mid-level, but there's also a level to it as well. And so you have upstream vertical ascent that's going. That's already, it's north and west of where you have these deeper, very cold tops in here, and overshooting tops, and you can see it in bits. But for the forecaster monitoring this here, you're also watching what's going back to the north and west. So it's telling you that you got a bit of a broader area of instability and concern for getting additional convection forward.
Okay, we're going to go up to Slido. For those that are virtual, we're having some connection difficulties.
Actually lost.
With Slido, so if you've submitted things in the last couple of minutes, I don't know that they're going to be shown up there right now. But we'll go back to the archive. I'm actually going to start with the last question, given that we can still access the sounding. The Topeka 0Z sounding looked like maybe an elevated mix layer came in. That was very moist, but the lapse rate is unstable from 850 to 650. Was there evidence of that in a previous days in the 7.15?
Don't know for sure what I can call that event. That was the case or not, when we did have an EML that was well defined, that was taken out through there. It's quite possible there was, so we did have
there was a lot of dry air.
Yeah.
In those clear areas.
Right.
Very clear cut.
Right. And the question was about previous days, I believe. So, yeah, so I don't recall what was upstream the day before in through there, but in this case here, though, you certainly can make the argument that there is an EML because not only do you have a trough, you can do a high plains region, but you have westerly flow off the Rockies, you can definitely see the drying going on through back here, and low level water vapor injury. So there's no doubt that there is a suggestion of at least a weak EML. The exact extent of how strong was a little bit tough for sure. But that that could certainly help to enhance the convection here later today, especially when we've got this enhanced moisture convergence going on in the low levels in terms of running that outflow boundary. I can answer the top question there with slide O.
Yeah, that's where I was going to go.
I can speak to that. We are eventually going to be transitioning to AWIPS 2. That's the bottom line in WPC. WPC uses both AWIPS 2 workstations and AWIPS. Our product generation is overwhelmingly almost 100% done with the AWIPS platform, very much like with other national centers. And EWC spoke with you yesterday, Karen, exactly the same type of scenario where we've got a lot of monitors. We're trying to buy good heat and buy monitors. We've got 3 or 4 AWIPS monitors, and the rest are AWIPS and the WPC that's in place as well. So our product generation for the MedWatch desk is done through AWIPS, but we have AWIPS there as well. And a lot of the procedures on both machines. In fact, I personally have every API channel in one procedure for AWIPS, not to mention all the RGBs. And then also with the AWIPS side, I have all the level 2 products uploaded through there. So eventually we're going to get to AWIPS 2, and I think that's more the destiny is, of course, for the service in general.
All right, so back to the audience here.
So I'm just curious, at this point in time, as a river forecaster, situations of perceptible water, all the other conditions coming together, I'm very concerned.
Sure.
The River Forecast Center. Can you talk a little bit about the collaboration process with the River Forecast Center at this point, either WPC or WFO, and what kind of conversations are you having with them at this point, and are you showing them some of these things?
So when it comes to the collaboration aspect of this, and we really kind of look at it from a DSS standpoint, with the MPD product in general, we want to put that out there in a sense as a guidance product meant for DSS support and for enhancement, at least for DFOs and the RFCs. But when it comes to active weather, this is especially the case with severe weather. The forecasters at the DFO level may not necessarily be focusing on flash flood hazards that are ongoing. They might be quite busy otherwise trying to deal with thunderstorm warnings, tornado warnings if you have an active outbreak. And the FOs may also be going their grids as well. A lot of time spent working grids, short medium range grids in particular, with the FOs. And so there may not necessarily be a lot of time with forecasters at the local level to be assessing some of these other hazards that could be evolving here when you have convection that's breaking out, especially when the guidance is not handling it well to begin with. So I think it's really incumbent upon the WPC forecasters to really kind of set the stage for that collaboration with the FOs to basically point out features that are of interest that can be driving different hazards, in this case flash flooding. And so it's meant, if nothing else, as a courtesy, just to reach out, coordinate, and try to have a dialogue, have a conversation on what might be happening moving forward. And that's what we actually did with this particular event. We're all the way back from the day shift and the previous night shift when we had to monitor the risk that was out, and Jenny had mentioned collaboration that has occurred between WPC and the local offices. So it's a two-way street, and it really kind of fits into that mold of a fully integrated field structure concept as well. So it's really kind of a win-win situation. And the more you talk, too, the more confidence the forecaster can have. It's not just us at WPC, but it's also at the local level as well. It also gets down to the RFC level as well. So we want to be talking about some of these features that are going to drive high impact weather.
And we're super fortunate too to have them surveys in RFC in our office. And so when you have an event like this, and I'm sure it happened this night as well, the RFC will come over and chat with us and say, hey, do you think this QBF is realistic? This is what we're feeding in for models. But then they'll also say, do you anticipate needing us overnight? How do you think this is going to play out? Should we staff overnight? Obviously, that's their decision. But those are the types of conversations that are really easy when you're co-located and they come over and say, hey, do you really think we're going to need this? And what do you think the impact would be overnight? And I know that was happening several times throughout this year. We actually had a couple of major flooding events in the city, and every time it was chatting back and forth between the two offices and making sure we had the support that we needed.
Okay, anybody else?
Luke Kim has a question.
And Andrew, I submitted this via Slido, but we seem to have lost the connection. Both you and Jenny have mentioned pretty active involvement in collaboration at this point. Do you have corresponding collaboration calls with SPC about overlapping concerns, as these weather hazards are evolving simultaneously?
Typically, we do not in this situation. We would not necessarily have SEC get involved in the coordination calls. So normally they would be with the RCs, even more so with WFOs in this situation. However, I think in the past, though, we have actually done some coordination with SBC. But of course, we're also looking at two different hazards as well. In this case here, with WPC, we're more focused on the rainfall and flash flooding hazards, not so much the severe weather. But actually, I do think in these situations, especially this day here, where we've both agreed, actually, thought was going to be probably north. Okay, real good stuff, real active heavy convections going to be probably north. And, farther south here, you can see at the starting point here, around series 8 and 1 time frame through there. So actually, I do think there is a window where we should be coordinating, I think, with SBC. If nothing else, to try to talk about the conservative forecast process. Ariel, I know you're right next to Kim there. Is that something that, of course, I'm maybe not there, but is that something maybe the SBC forecasters would appreciate?
There's certainly going to be overlap between the MPDs and the MCDs
yes.
in terms of communication of timing, location of initiation, and sustenance. That
Absolutely.
There probably would be opportunities to be able to develop some common operating plan for how the convection is expected to evolve into these episodes. And but I'm not going to speak for anyone.
That's fine. And actually, one thing I just wanted to point out, we've actually had NPDs go out where we've made reference to those actual NCDs that have been put up on SEC because the line of thinking is similar. Convective initiation is a critical part of this, right? For the NPDs for WPC, we want to have that lead time. And when we say flash flooding is possible or likely, we don't want to be putting out the NPD when convection's been ongoing for 3 or 4 hours and it's already flash flooding on board. We want to have to lead time. We want to be on the opposite side of this, okay, where we're thinking about convective initiation. You draw an area. This is the most likely area you're going to see flash flooding. All right, that's ideally where we want to be in that situation.
All right, I think we're going to do the last question from Slido. This will be, I think, for Jenny, Western Region Sioux. Was the FFA extension into the Kansas City Metro during the evening covered well in the 10 o'clock news? Can you comment on the relationship between the TV networks and Pleasant Hill regarding NWS chat usage and communicating the flash flood threat? And I will ask that one since it seems to fit in with our time frame here in the sort of 0 to 3.
Yeah, we can definitely address that in the next block too, because we are going to actually show the expansion of the watch in the Kansas City area, but I'll make sure I do address the timing, and that actually was very purposeful to get that out before the 10 o'clock news, so I'll make sure I address that when I talk about the watch.
Okay, are you ready? Chat a minute.
Yeah.
Okay.
All right, so we'll go ahead and jump into the next portion. We're not going too far ahead in time, but we are going to focus a little more on the local area in the Kansas City CWA and into Topeka's as well, as you start to see this scenario developing. And we had already hinted at this as we were seeing the visible and the IR with those towers starting to go up. We're starting to see overshooting tops with the convection that's developing in northeast Kansas. And that's definitely our focus during this period because we're starting to see things ramp up for the evening. Again, worried mainly about flash flooding, but still seeing that to me looks really impressive on the IR. If you're just kind of calibrating yourself to what you would expect during severe convection, where you see some of those overshooting tops, it's very robust looking from the IR and the visible as well. So focusing in on that, if you didn't have that atmospheric perspective, if you didn't have that skinny cape profile and your saturated sounding, you may look at just that satellite and say, maybe we're expecting severe weather right now. So, Chad, you want to look at that for me? The other thing to really focus on, so we've identified this boundary. You can see it feeding into, and it's hard to see here if you're not familiar with the geography, but Kansas City Metro is basically right here where you see some complex geography in the Kansas-Missouri border. That's part of the northern part of the Kansas City Metro. And I should point out what we're looking at here. We're familiar with the VIS and the IR up there, but we're also looking at our lowest level reflectivity over on the lower left. And then on the lower right, that's the radar accumulated precipitation. And we'll point out some values here in a little bit, but you can kind of see overall where this is focusing. Again, this boundary that's kind of building into the Kansas City Metro. And can you do the 4 panel, and we'll rotate, zoom in on our radar. There we go. So if you look at the radar by itself, and we'll just loop through this, you see a lot of separate echoes. It looks fairly progressive when you're looking at it from this perspective. And it doesn't scream to me flash flooding just looking at some of these echoes. You do have training, but it looks like it's moving. You see additional development back to the west, but again, these higher echoes look like they're moving pretty quickly. But if we jump back to all 4 of our panels, just an N. We have an N. I didn't tell Chad I was going to make him do number.
Sorry.
I apologize.
Oh, got it.
There we go. So if you look at the IR,
First thing on the job, sorry.
it's not an AWIPS keyword. So if you look at the IR, and especially the overshooting tops, you really get a sense of how stationary these updrafts actually are. Even though you have your super progressive radar imagery, when you're looking at that IR, focus in on these colder tops where you're starting to see the darker reds into the black colors. Those are sitting in the same area over and over again. And even though you know that those cores themselves were moving, when you look at those tops, they're sitting in the same spot. So this is already a problem. This is basically the 0Z to about 2Z period. So this is evening. This is just when things are starting to get going. You're already seeing this kind of stationary motion that adds onto those super efficient rainfall rates.
It's really not what you'd expect by looking at the radar.
Definitely not. You see a disconnect between how quickly it looks like those echoes are moving and how stationary they look in the satellite imagery. The other thing to point out, there are some issues with getting hail data, but when you move into a metro area like Kansas City, if there's hail, you're probably going to know about it. And we were not getting any hail reports out of these. You look at those overshooting tops, you think this is pretty robust convection and probably getting some hail out of it, even with those really high freezing levels, we weren't getting any. So all of these overshooting tops, these really impressive cores, it's all liquid. So all of that is accumulating at the surface. And Chad, if you want to arrow over some of the rainfall totals as we move forward, you can see 3.1, and I think this isn't even quite the end of the loop, but you're already seeing 3 to 3.5 inches, almost 4 inches estimated. This is a dual pole radar estimation, and it's actually doing really well in this scenario. So already within the last couple of hours, you're accumulating up to 4 inches of rain in this kind of northern part of the urban core. You want to jump to the watch for me?
Yeah, that's where I was headed.
So this was the expansion that was done of the watch. You can see it before was mainly focused up north of Highway 36, which goes from St. Joseph, Chillicothe eastward. North of that line is where the watch was before. It was pulled to the south and even canceled up to the north to really focus in on this southern shift of what we were expecting. All of those synoptic ingredients were still in place. You still have those really high peak watts. All of that was still verifying, but what we were really focusing on as being different as we move forward was where that boundary set up and where those cores were developing. So environment was still really favorable. Core flash flooding like we expected, but But as we saw this scenario evolving, where the boundary was laid out by the MCB, where these scores were starting to develop, we really wanted to focus on the Kansas City area. And in terms of messaging, we really wanted this out before the 10 o'clock news. We wanted to make sure that this was communicated. But I will say that within the last couple of years, we've done a lot more with these kind of short fuse watch products, because I would probably before the MPD era, I think it was more of this watch as something you put out in the morning and then you leave it, and all of your communication is warnings after that. But in this case, we really wanted to highlight this threat even though the rain is already ongoing. We really want to let people know that yes, flash flooding in Kansas City is our main threat going forward. We want to make sure this gets on the news. We want to make sure people know about this. Even though that threat had maybe been communicated broadly before, this really tells Kansas City this is going to be your issue over the next several hours. So even though you already saw that rain ongoing, even though you were already starting to see some higher accumulations, I still think it was really valuable to expand this watch out and make sure that everybody knew this isn't the only round we're going to see, this isn't the only threat, and this will continue to be over the period. So that was communicated really well. We have all of the local TV stations up on our situational awareness display, so you can see whether or not it makes it onto the news. And fortunately, that got on early enough that they had enough time to update the graphics and get it going. But we do also communicate with them in NWS chat. We do make sure that everybody sees it. We'll actually put a chat in there, even though the NWS bot, if you guys are familiar with it, an automated system that would pop in and let you know that the watch would expand it. We'll also get in there and chat and just make sure everybody saw that and that it's expanded so that it's messaged well. And the media will ask questions if they have them. They know they can reach out to us and communicate back and forth. And we've always had a really good relationship there with the local media. So that was definitely communicated. And we really made sure that message got out before the flash flooding was really a huge impact for that thing.
All right, let's turn it back to the audience here first.
Thanks. Jenny, you kind of hinted at this already, but you know, as I look at flash flood watches also, I've been wondering if we need to change our entire paradigm in the Weather Service. I mean, Ariel showed yesterday how critical it is to look at CI and analyze the radar and the satellite data and everything. I'm wondering if the same thing has to happen with flash flood watches, where WPC maybe takes the lead in coordinating that watch now and doing it as the production's developing instead of 24 hours in advance. Because I can tell you, I looked at our office, our long lead time flash flood watches do pretty poorly overall. And I don't know if that's the same everywhere in the country, but it just seems that this analysis argues for a much different paradigm than we're going to do. So I'd be curious if you can comment.
Yeah, I definitely agree with that. It has been a paradigm shift over the last couple of years. It just, you don't want to watch to sit there and it's not good. But you also don't want to judge yourself for that watch earlier in the morning. That's where the ingredients were setting up. That's really where it looked favorable. And we were recognizing an environment that was conducive to flash flooding. So as that shifts southward, I think we should be able to move the red area southward. I think we should feel like it's okay to update that watch product and move it southward. Things are focusing further south. SBC does it with their outlooks just based on, okay, we know we're going to update it several times a day. So it's okay to move that threat area as the meteorology changes. So I think we need that thought process as well. Don't keep a product out just because you feel like it's a long-phase product. The ingredients were all there. It just set up a little further south, and I think that southward shift to the watch and to the MPDs, that was really important.
Okay, I got the floor here next to you. One of the GOES-16 level 2 products that we're going to be getting is a rain rate QPE product. Given that we've got a bunch of different methods for looking at QPE right now, either single radar or MRMS, we'll have this GOES product as well. How do you see all these different things fitting in where they could be definitely giving us different answers? Is there a future for maybe ensembling this type of information for us to use?
I think it'll be a learning curve because there's a lot of, especially when you're looking at your rainfall rates and you're comparing them to the gauges and decide, okay, Google is the answer for tonight. You tend to really focus on that one tool that you've decided is working well for you for the night. So I think it's going to be a learning curve to bring in some of those new data, but I think it's going to be really useful to have, especially if you start seeing that maybe I'm not getting the answer that I'm looking for from the radar. Maybe I'm getting better values from satellite. So perhaps not ensembling, but having that mental ensemble picture would help a lot, where you're considering more than one source and continuing to consider more than one source even as the event evolves. Perhaps radar was doing well at the beginning and now it's not doing as well. So kind of keeping that open mind for different tools, especially when it comes to something where we're used to focusing on just radar. I think having that open mind and that ensemble framework, at least mentally, will help a lot.
Any other questions? Ed?
So, it works. Only took 3 days. So, Jenny, it's a really nice case, but I know you guys had several events, right, this summer, big events. Would you say that were there other lessons learned? Were they didn't go as smoothly as this, or did you have some other issues that came up?
Yeah, this was the first of at least 3 major flash flooding events in Kansas City. And I think there were definitely some lessons learned from this event that I will touch on a little bit later, especially with regard to staffing considerations and how we handled that overnight. But it was definitely the summer of really high PWATs. I feel like we saw 2.5 to 3 PWATs all the time throughout the summer. And I think that almost desensitized us to some of those atmospheric ingredients as well. So yeah, we did have several events. This was the first, so there weren't a lot of lessons learned to bring into this event. But I definitely think there were some afterwards that helped us through the next few. And I'll make sure I touch on those when I get into the next segment as well.
All right, let's just real quick a couple of the slides. By the way, the question at the top, we're going to save to the end. But I didn't want the others. Actually, the very bottom question. We didn't show it on here specifically, but do y'all remember recall flash flood washes issue to the west?
That is a good question. I don't remember if Topeka expanded theirs either, since that's a local graphic. And even if this was pulled up, from the gridded database, sometimes if you send it at different times, you don't always capture the correct one. So I'm not sure if Topeka expanded theirs or not. I would have to check that. But the offices are completely and continually in coordination as well. So we want to make sure that they were aware of that situation too. And it looks like a lot of the cores were kind of progressive and moving out of their area, so they may not have thought it was necessary. But definitely that coverage does go on, and we want to make sure those products do line up if the threat area continues into another CWA.
Okay. One more case for folks who were sort of getting into the event. This is more, I guess, related to the update that do either Pleasantville or WPC have access to Sierra's infected layer precipitable water. So were they used in this event? Now, again, just for everybody's awareness, this is a product that was brought in forecast offices of these regional LTMs. This is not an SDN / operational product per se, but it's a good question. So maybe we'll let you go.
We do have access to it in our office. I know that we do look at it during events. I'm not sure if this one specifically, if it was used then, but it definitely has been used by our office previously, and it's been very helpful.
Yeah, so in WPC, we actually do currently have the enacted LPW Sierra. We are using that operationally. For this particular event, we did not have the enacted layer PW version just yet, but we had the prior version, and it was used in this situation for this particular flash flood event. I personally look at this every day when I come in on the MedWatch desk, and it's is very advantageous in so many ways, because when you think about LPW, it's not, and this is where you differ from the water, traditional water vapor channels. You can really sort of dissect the entire column and see where the moisture is more concentrated throughout the layer. So, and in this case here, we actually had a convection of moisture that was coming out of the east of the tropical Pacific. It was coming up through Mexico, up through the high plains region. So you had a high level component of moisture that the LPW did reflect. And so that gives you an idea of what kind of rainfall efficiency you could be having. So you're looking at heavy rainfall rates in that situation. And in a sense, the Zuzi peak of sounding that we looked at earlier sort of confirmed that. We had a very deep column of moisture that was in place. So we used it operationally. We used it quite a bit as well for atmospheric river analysis as well.
Let's move on.
Okay, so we're going to jump a little bit forward, and I think we'll let it continue to loop here, but this is basically going from the end of that first round where you saw all of that precipitation getting into the northern Kansas City metro. You see your kind of ranked totals there, where you're looking at about 4 isolated 4.5 inches on that radar estimated precipitation. But overall, you're starting to see that bulk of precipitation that moved down, kind of your park boundary has started to focus a little further to the east. And thinking about some of these atmospheric considerations, a lot of that developed in the daytime, where you had a little bit of a diurnal heating over in northeast Kansas. So kind of that forcing that initially got those updrafts going in northeast Kansas has waned a bit. Your MCV has moved through. Potentially your boundary has been impacted by some of this ongoing precipitation. So just looking at, especially the beginning part of this loop, it looks like maybe things are starting to wane. Maybe this was our big show for Kansas City, and we're starting to move on. So that was kind of the impression as we started this loop. But as we get a little bit further towards the end, especially focusing on the radar, but you can also start to see it in the infrared as well towards the end, you're starting to see all of these cores going up. And now you think, well, that's probably that little jet that I was worried about. Now it's starting to fire up. So looking at these new cores starting to develop, I know we've addressed the parallax error a couple of times throughout this conference, and it was something to just be aware of again this time, because where do you see these new cores coming up? If you just looked at the IR, it looks like maybe a similar location to where that rainfall was feeding in before. But as you look at radar, and especially your accumulated precipitation, where you see kind of these new streaks developing, it's further to the south. So we're starting to see perhaps that boundary was influenced by that previous convection. Maybe it's pushed a little bit south. Maybe you're firing a bit of an elevated boundary at this point, since we're getting further into the night. But you do see a southward shift to where those new cores are developing. They're still feeding a similar way. You still have that similar storm motion, similar environment to what you had earlier, but a southward shift to where those cores are developing. So this is another place where IR is very key. You've got a lot of cores going up on radar. If you're just looking at that radar by itself, still pretty messy. You do see the little jet going. You do see kind of where some of those cores are focusing, but that robust development that you see in IR, you can't pick that up through radar alone. So I think that was really important in this case, and especially in the second loop. I'll make sure I address this, and Chad, I'm going to make you remind me if I forget. But this is where the 1 minute versus the 5 minute is going to get really key as well. So this is just kind of setting the stage for round 2. And I believe you were going to talk about the MPD as well.
Yeah, so going toward the 60 time frame, the convection, of course, as Jenny pointed out, the most organized part that they're going over into areas of Missouri here, west central Missouri. You can see some of the very cold cloud tops if you're there. Still some overshooting tops associated with that. Also, you can see here on the radar showing the stronger reflectivities at that point. But one of the key things that we were looking at toward the end of the expiration of the first APD, which was again at 6C, was that, you know, around 4:30Z through 5Z and 5:30, especially in here, after 5Z, we're starting to get all this convection here that's regenerating. And you can sort of just, you could stop the, right the end there, Chad, stop the loop. Right there, so this is right at 6C. And at this point, you've got a nice little V signature right here. This is a nice looking convective wedge signature, rather classic when it comes to flash flooding analysis, where you have the upper level divergence, you're getting strong forcing being focused in the low levels. Already, in this situation, we know we've got at least a modest low level jet, 30 knots or so, perhaps a little bit stronger at this point with nocturnal processes going through a midnight time frame. And so, stronger moisture convergence and instability transport out ahead of that old synoptic boundary that was off to the north and west. So that is in place, and in the mid and upper levels of the atmosphere, okay, you're actually getting a lot of divergence in there, and that convective wedge signature here that you're seeing is really kind of a tall tale sign that they're going to have additional organization for convection moving over, at least for the short term. Okay, it doesn't have to be, you know, another 6 to 12 hours, but let's say it's, you know, 3-4 hours or so, something like that. That's what you're going to be probably concerned about when you start seeing a feature like this set up. Now, we already, of course, have the convection downstream here, but this is brand new convection. You have the nose of the low-level jet overrunning the old outflow boundary as well, right? And then, of course, you're seeing that split there, so you've got some level divergence going through the region there. So you have a lot of ingredients in place for convection to sustain itself. And, of course, we've already had convection through that area as well. Just the focus up here is gradually sinking down here to the south, but you do have areas here across already central Kansas, around the Kansas City metropolitan area, and adjacent areas of west central Missouri where you've already had heavy rains. So the antecedent conditions are quite wet. So you don't really see signatures like this popping up over here. You're going to be concerned about the track of this and the evolution over the next few hours, right? And so the messaging for the next MPD, and we can go ahead and go to that, was that we still have an elevated threat across some of the same areas that we were looking at earlier. Hatched area, East Central Kansas, going through much of West Central Missouri here. You can see the 850 winds here. This is off the wrap at this point, generally 30 to 40 knots, a little bit stronger than what we had back in the Jersey time frame at that point. Forecaster, in this case here, did a really nice job just trying to highlight the area where you had the max PWs at this time. Of course, they were already very, very high. You already had a very tropical air mass in place. And actually during the Q&A, I mentioned the LBW product. That was actually showing a very high level concentration of moisture, high up, deep up in the atmosphere, 500 millibars, okay, where when you get very cold cloud tops like what we were seeing, especially with overshooting tops, you're really maximizing that efficiency through the rainfall processes. So you think about the microphysics going on to enhance the rates, okay? You're taking advantage of everything that's in place, like the instability and the moisture to get those overshooting tops in there. So the rainfall rates are going to be very, very high in that situation. And so that's actually what we had already been forecasting. You can see in this MPD here, we're talking about PW16 2 1/4 inches through here. The earlier MPD had talked about the rainfall rates being upwards of 2.5 inches per hour. And some of the dual bowl estimates, Jenny, had actually indicated that at that time. So for this MPD here, so we made a specific mention about the experimental GOES-16 imagery showing the details for the overshooting tops, very cold tops that were in place. And we also made a mention in here about the zero-Z sounding, again, showing how high the wet hole zero heights were, in this case here, 15,000 feet. So again, indicative of a tropical air mass where we've got a lot more rain processes ongoing. So the big concern at this point, and the models at this point, we're actually starting to gradually get a bit better here, especially the CAMS guidance. The global models, actually, since I wasn't on overnight, I couldn't really be for sure certain where they had the axis of heavier convection. But the high-res guidance was gradually coming down farther to the south with the organization of this activity through here, which ultimately ended up panning out to be correct for later on in the night. So that was the MPD update we did, and that went through 10Z. So we were expecting additional flash flooding through the balance of the night. And this information would, of course, be coordinated with Jenny's office and the adjacent FOs impacted for this event.
And this is a tough time. If you look at our 6C time frame, we have a shift change that happens at midnight, and that's where both of your evening shifts leave, and you are left with 2 people by themselves. We did hold over the evening shift through at least we issue our climate at 1:30. It seems arbitrary, but it's the duty that needs to get done. So if there's busy weather going on, you're going to hold over somebody to do that climate. But this 1 o'clock time frame is where you're making that decision. Are we going to continue to hold over our evening shift? Do we need to get someone else in here because maybe they work tomorrow? What do we need to do for the staffing consideration right at 1 a.m.? This is tough because you see this starting to feed into a more southern area than where we had before. Obviously, your flash flood guidance up here, where you've accumulated 4 to 5 inches, is going to be 0. But this is moving into a new area. They did not have any rain from that warning system the day before, so you're starting out with pretty much fresh flash flood guidance moving into this new area, somewhere that hasn't been impacted recently. However, you do have that low-level jet contributing to that same environment that you had before. You already saw what these rainfall rates are capable of producing, what this environment is capable of producing. Moving into, this is still the Kansas City Metro. If you can use this as kind of a cheat sheet where our radar is located is the southeast corner of the Metro. So if you're basically west or north of there, you're probably in the Kansas City Metro. So this new area that's feeding in is still very urban Kansas City. It's still definitely a concern, even outside of those flash flood guidance values that you have. It's an urban area, so if you get 3 inches, you're probably flash flooding, regardless of your pre-existing conditions. So definitely a tough choice to make right there going into that 1 a.m. time frame.
Yeah, one quick question, Jenny. In the timeline here, I know we can't see the polygons, the one polygons here. Now that we're into the 60 time frame, take us through quickly the evolution of your flash flood warning issues.
Yeah, definitely, and that's, I meant to bring that up, so thank you for saying that. Yeah, so initially as that first stripe of precipitation started accumulating, flash flood warnings went out as early as about 9:45 that evening, and then continued further to the east as that precipitation continued to accumulate. So we did have several flash flood warnings in effect for the northern half of the Kansas City Metro and then points eastward from there. There were a couple of water rescues in the Northland, just where some of that flash flooding was impacting roadways, especially since it was a little earlier in the evening. There were still some people traveling around. So there were a few water rescues and some flash flood warnings ongoing at that time. And then as we continue to evolve into the second part of this, where you can see that accumulated precipitation spreading southward, additional flash flood warnings were issued for those as well.
Okay, audience folks here, questions, comments, please.
And if you're still thinking that's okay, because we're going to continue with the second part.
Yeah, I got it. This work. I got a question. I was starting to ruminate about the 2 time periods earlier, about the disparity between the overshoot top apparent motions and then the motions of reflectivity. And I've seen this before, and one of it, seems to be that, that once you get up high enough, there, the pulses are either embedded in a different steering flow, or you have pulsing that occurs very quickly and it descends, but then the lower level core is moving along. So it might have something to do with that disparity that you're seeing here as well. So just some thought of this.
Yeah, that's a good point. And like we talked about earlier, your batter steering flow off, where we were concerned earlier where that convection was in Iowa. So our upper level flow is not very good in the areas where we did see convection develop.
Yeah, exactly. Actually, sort of along the point that you're making there, Jim, we had actually talked about this a little bit during the setup for today's presentation. And last week, we were coordinating over satellite imagery. One of the features that I noticed, you sort of see it a little bit here in this loop, so with the infrared. In the previous segment where we had the convection breaking out back here, the initial batch, around Kansas City, which led to the first flash flood point for Kansas City metropolitan area. You have a number of overshooting tops back through here, and the situation, juxtaposed with the radar showing convection will continue to move downstream here, but you had sort of a hint that the overshooting tops were kind of stationary or semi-stationary there. One thing that I pointed out, or at least had noticed, and I don't know that we would have noticed this even back in WPC overnight on that shift, and actually the next day when I came in, I didn't necessarily pick up on this, but you actually had a case where it looked like you had a bunch of gravity waves coming out of these overshooting tops. You could actually see almost from a fluid dynamics standpoint, you could see the perturbations just percolating away from the tops, and then you had basically converging gravity waves, which in essence produced additional colder tops and maybe new overshooting tops. I can sort of make that point. So you sort of have a lot of very dynamical things going on in through here. You had one overshooting top, gravity waves going out, and an adjacent overshooting top, gravity waves from that. They converge, and then the merger of those two ends up producing additional colder cloud tops, and at least the appearance of additional overshooting tops. And so that's ongoing in through here. It's very suggestive of a high-level degree of organization, just from an NCS standpoint, not necessarily at one particular spot point, but at least collectively over the region there. It implies a lot of organization that's going on. And so I think when we saw that going on, from the satellite perspective, in time, the manifestation of that sort of eventually translated into the radar signature, where you didn't necessarily have these sort of linear bands just gradually progressing down to the southeast, but eventually you had everything kind of congeal into a more organized, heavy axis of rainfall and full-fledged NCS at that point. Just some observations.
And I think the only radar comparison you could possibly make is with upper level MRMS, multi-radar, multi-sensor, which has a 2-year update. But even then, I think it's really hard for any of those sensors to keep up with the pulse frequency and the activity going on in the upper regions of the storm that we're seeing in the 1 minute.
Right, right.
Literally, you can go from down in queue to overshoot in 5 minutes.
Exactly.
And that's a volume scan time.
Sure. And we saw some of that ongoing here. This event.
And just to be sure we point out, we did jump ahead, if you're seeing the differences in the imagery here, we jumped ahead to the 2 a.m. to 4 a.m. time frame when we had the second round come in. And if you look at the radar imagery, you can see why perhaps Topeka did not issue a flash flood watch if they did not, because these storms really seem to know where the CWA boundary is. And if you remember actually from the water vapor imagery before, you had that dry air moving in from the west, so you've got this perfect feed of moisture right on the edge of where that dry air was coming in, and it really is all centering on that Kansas City metro area. You're really not seeing those values further to the west. And every time you see this progressive core move forward, you think, this is it. This is finally it. We're going to be done. It's going to move out, and then another core comes. So this is where we're really going to focus on the IR, and I'm going to have Chad continue to loop the 1 minute while we look at this. But then we're actually going to compare it back to the 5 minute to show you where this really becomes invaluable. So focusing on these overshooting tops, even though you see kind of these edges to your precipitation, you see these progressive cores again on radar, you really still see that continued focus in the CWA. You're not seeing an end to your overshooting tops. You're not seeing signs that your convection is starting to wane if you're just looking at the satellite. So even just looking at that radar, if you're thinking this round is over, that IR is going to tell you that it's not, and that you're continuing to see that convection developing. Like Andrew was talking about, you actually see some overshooting tops kind of develop back off of previous overshooting tops. you're really seeing this pulsing over the same areas with all these overshooting tops. And again, very impressive values, very cold tops on these storms, not producing any hail. This is all, again, liquid. But once we turn on the 5-minute imagery, it'll be in the upper left over there.
We're gonna have to jump back.
Oh, we're going to jump. So just remember what this looks like, where you're seeing this just very continuous and very smooth appearance to your overshooting tops. Once we flip back to that 5-minute imagery,
Yeah, we should show it though, because
yeah, let's do it. 'Cause I think that'll really hit that point home where someone was asking about the 1 versus the 5-minute.
so we're going back to 1 to 3 feet.
Okay, that works. So once we get this looping, you'll be able to compare the 5-minute in the upper left to your 1 minute in the upper right. And you'll be able to see how you don't get that continuous sense from the 5-minute. It's a little bit jumpier. Maybe you're thinking that these are new 4s versus that previous 4. You really see a difference, and you actually see a little bit more of a progressive nature even to that 5-minute, because you don't get the sense of that continuous redevelopment even on the northwest side of these cores. So,
All the imagery is there now.
yeah, okay, so all the imagery is there, so you can compare between the two, and it just, especially, I think it was right around 2Z, right where Chad's putting his mouse, you see one of these overshooting tops really persist in that same area, and it looks like it's moved out in the 5 minutes. So I think this is another case where that 1 minute imagery really tells you what's going on and really tells you about the persistence of this case, and that the rainfall is going to continue to accumulate in that area. So
Actually,
you saw a similar thing with the second one as well.
Chad, if I could, you could slip it up there. So kind of go back to the point I was trying to make with Jim about the gravity weights. You sort of get the sense of what's going on here with these individual overshooting tops which go up, relatively stationary, and then you sort of have this propagation of energy away that actually, especially for this guy over here, you see something that's propagating all to the west and northwest, and you basically have, if you could just go ahead and look that through actually, Chad. Right there, in this general area, that last overshooting top seems to be the manifestation of this guy, right there, those two right there. And you can see the enhancement with energy that goes out from both of them in there. You really kind of get that new overshooting top, which really helps sort of sustain the convection down here also as well. I just wanted to make that point. Pretty fascinating stuff.
So we'll show just some observations from around the Kansas City area to kind of tie all of this back in. These are all of our storm watch gauges that we have here in the Kansas City Metro. These are all really accurate gauges. We can compare them back to the VTARs. Chad can compare the one right next to his house to his gauge. These are all really accurate, and they are continuously updating their tipping buckets, so we're able to get those data in real time on the office. We'll show an example of just one, but I wanted to give kind of that sense of how many gauges there actually are, and how we can feed these data into kind of that real time to compare, and I think that'll help our satellite estimated precipitation rates as well, once we do have that. But this is an example from Indian Creek, and this is at 103rd Street, so that was where some of the major flooding occurred that we'll show in a couple of minutes. You can see a jump from less than an inch to about 5 inches within, I think that's about an hour and a half over that period. And I wish we could pull up the archived rainfall rates because they were incredibly impressive as well, which you can kind of just assume from that shape of the graph. But extremely, extremely efficient rainfall and some validation to those rainfall amounts that we did see. And then these are just some images from the storm. Areas that were really impacted were the northeastern corner of Johnson County, Kansas, which is a very urban area. This is Indian Creek. And this is actually a really big deal because Johnson County, Kansas, and kind of into the Kansas City Plaza area have done.
Okay, they got one out.
On flood
We've got one up.
mitigation to make sure that this doesn't happen.
It just happened so quickly, the front walls caved in and just water gushed in on us.
Coaches, it's a restaurant, it's just off of 455. There were 2 cars inside that actually had to be airlifted out through the roof, and it was filled almost all the way to the top. The water actually did push in the front doors and filled the restaurant with water as well. So I don't think this would have been used in this scenario if we didn't have those 16.
Yeah, I totally agree. I really look at GOES-16 as being so revolutionary that you actually get to see you get to read all the paragraphs of the book over these types of events. So high impact event, in this case flash flooding, GOES-16 data, 5-minute, especially the 1-minute entry. It really tells you all the words to the story. You don't skip any paragraphs. I think I would try to make that sort of analogy if I could. So I mean, with this imagery here, you're seeing everything happen as it occurs with 1-minute data. So you get to see a lot of details from the spectral standpoint all the way through the temporal and spatial elements here for everything that happens with this event. So you don't miss anything. And Jenny and others out the FOs would certainly agree that lead time is critical. It's critical for us in WPC for warning operations. It's of the utmost importance, and so GOES-16 really facilitates that.
Okay, and I see you all have, I think we'll summarize your couple of key takeaways here before we end the session.
Yeah, so these were my 2 takeaways with WPC. I just really wanted to point out how GOES-16 ABI imagery concert with other conventional data sets out there, rubber air data, radar, surface observations, provide the ultimate check, reality check for model performance. It's one thing to go ahead and actually assess what's going on, in real time with the evolution of heavy rainfall and severe weather, okay? But even before that first convective initiation gets going, okay, there's a lot of things that GOES-16 data can do. It can be concert with other data sets to really kind of provide that model diagnostic. It's really key. In this case here, the NAM and other global models didn't do very well. The high-risk guides didn't do very well. I pointed out how the visible imagery and also the infrared imagery late the afternoon before was not handling that MCB particularly well. Okay? So the guidance was having trouble with a lot of the ingredients that were coming together for this event. The MCB was important because it really kind of helped to anchor a boundary that ultimately was one of the ingredients for getting the lift to initiate the protection later that evening. So GOES-16 was pivotal in actually trying to identify errors with guidance. And so at the bottom here, I'll just point out the GOES-16 ABI provides means for key decision support in difficult forecast situations. This was a very hard forecast that went back at least a good 36 hours prior to the end of the event. SBC and WPC both were thinking, well, the convection's going to fall to the north. And well, it ended up being a couple hundred miles farther south. And it was a very significant flash flood event for a very highly populated area. So the GOES-16 data that we were identifying in our NPDs was meant to try to enhance that DSS on behalf of the WFOs and other partners within the agency. So, and given its high spatial and temporal resolution, I really do think that meteorologists can more accurately assess the life cycle here. Of course, we're basically going from the beginning to the end, the high impact event in this case here, but you can assess this cycle here of high weather impacts, whether it's severe weather on one hazard or it's flash flooding on the other.
Yeah, and I definitely think that an area where we have been focusing and we need to continue to focus is this kind of tenuous area between your watch and warning phase. And that's where GOES-16 has really come in, because you have kind of these longer fuse products we've identified from our atmospheric situation, from our soundings, that we're expecting flash flooding. And once you get to the warning phase, that's basically QBE versus flash flood guidance versus what you know about your urban area. But in that pivotal time between that watch and warning, that is where GOES-16 is just completely invaluable, because you can see where are things setting up. Where is my threat area focusing within this watch area? Is my watch area shifting? Is my threat area shifting? That's where it was really key to help us figure out how this event is setting up before you start to see the whites of dyes with the accumulated precipitation. And also in terms of DSS, our partners and especially our media do not have access to GOES-16 yet because it is not operational. So they are not able to pull this up in real time. They're counting on us to look at these data and tell them what that means for them. So make sure that they are updated, that they are communicating the threat appropriately. And you know, a flash flood warning is a flash flood warning. We have tons of them per year. But being able to give that additional information, that's a flash flood warning, but this is where we're seeing things focusing. This is how quickly we think rainfall is going to accumulate. This is how stationary these cores are. All of that information communicated to the media and to the rest of our partners is really what we need to be doing. Even once they have the data, they still don't have the time to interrogate it. So giving that final piece of here's what we're seeing in the satellite, how does that impact the evolving situation, and where do we really need to focus our efforts in communication. So I really think that's where this was invaluable throughout the scenario.
Okay, let's give Jenny an intro round of applause.